Okay, the following are notes for 11.1. This is areas of parallelograms and triangles. So I want to talk about the formulas real quick before we get started. You already know the formula for the area of a triangle, and the area is 1/2 times the base times the height. You can also think of this as the base times the height divided by 2. They both mean the same thing. Multiplying by 1/2 is the same thing as dividing by 2. So here's the interesting thing here is that this is my base, okay, and I think of the bottom of the triangle. That's that length here. Now the height of this triangle is the vertical distance down to the base, and it's what forms a right angle here. This is my height. Okay, a lot of times, we've been seeing triangles whose the top of the triangle is in between these two base points, but you can have the height out here. So it's the actual distance from the very top of the triangle to the bottom. Okay, and it's always perpendicular. So here my base is equal to 4, and my height is also 4. So if I plug it into my formula, my area is going to end up being 4 times 4 divided by 2. And so my area is going to be 16 divided by 2. And so then my area, 16 divided by 2, is 8. And we'll call that units squared. Okay, square units. So there's my area for that triangle. Okay, over here, we have a parallelogram. Okay, and so I'm going to call this length the base down here, and I'm going to call this length here the height. Okay, and it's it's the distance between this top segment and this bottom segment. That's my height. Okay, and so the area of a parallelogram is something that's very familiar to you, and that's the base times the height. Okay, this is the same type of formula that we would have for a rectangle. And what I want to show you is that, when I make this right triangle here, I have this area here. Well, what I end up getting is a triangle over here, and that triangle has the same area as that. And so I just end up having a rectangle. So basically what you can think of is that if you take a rectangle and cut a triangle out the side and you move it over, then it gives you a parallelogram. So here's what I know. I know the base is 1, 2, 3, 4, 5 units, and my height is 4. So my area is going to be 5 times 4, which ends up giving me 20 units squared. Okay, so these are the formulas that we're going to use. Some of these triangles are a little bit tricky, and we'll have to find the perimeter and area of them, but we should be fine. So the first one I want to do is number 1 from your notes. And let's go ahead and find the area of this real quick. Here is my base length, and here is my height. Okay, it's always that vertical distance from the very top of the triangle to the very bottom. And so my area is equal to base times height divided by 2. And that's going to give me 18 times 12 divided by 2. Now, simplifying this, you don't really need a calculator to do so. I know that I can take half of 18 here. And so that's going to give me 9 times 12, which ends up giving me 108 millimeters squared. And that's my area. Now, we're also being asked to find the perimeter, okay? And that's going to require a little bit of work because I need to know this length here and this length here. So let me erase my base and my height. I'm going to call this length over here x. Okay, let's find this length here first. Now, this length is formed by a right triangle, and this is my hypotenuse. So I can set up an equation for x and say that x is equal to this length squared, which is 12, 12 squared, plus this length down here, which ends up being 28 squared. Okay, and I'm just using the Pythagorean theorem here to find x. And so if you simplify this, you end up getting that x is equal to the square root of 928. All right, you would need a calculator to do that. Okay, but this is an exact measurement. And I'm just going to leave it like that because I'm going to plug this into the calculator later to get our exact perimeter. And so now let's do this for this length here. I'm going to call this y. Okay, now notice that I have another right triangle here. And this is the hypotenuse of this this right triangle made uh, by finding the height and knowing this distance here. So I know this. I know that y is equal to the square root of 12 squared plus 10 squared. Now this one you might be able to do in your head, but you end up getting that y is equal to the square root of 144 plus 100, which gives me 244. Okay, and this is an exact measurement. All right, we'll deal with that later. So now what I want to do is I want to find the perimeter. And the perimeter is just all these side lengths added up. So I'm going to take 18 plus the square root of 928 plus the square root of 244. And if you plug that into your calculator, you end up getting that the perimeter is approximately 64.1 millimeters. Okay, now you could express it like this if it was wanting the exact value, but we want you to plug this into your calculator and find that. So that would be the perimeter and area of that triangle. Okay, but we have to use what we know about right triangles to solve that. Okay, let's go ahead and look at number 2. Okay, it wants us to find the perimeter and area of each parallelogram. Now, what I know about this figure, if this is a parallelogram, then I know that these two segments are congruent, so this is 14 yards. And I know that these two segments are congruent, so this is 7 yards. Okay, so if I wanted to find my perimeter first, my perimeter is going to be, I have two 14s, so I'm going to take 2 and multiply that by 14. I have two 7s, okay, so I'm going to add 2 times 7, and that's going to give me 28 plus 14, and my perimeter is going to end up just being 42 yards, okay? So that one's pretty easy. You don't need to do anything to find that. But now I want to find the area. Okay, and the area is a little bit tricky because I need to have my base and my height. Now I know my base is this length down here, but my height is right here. All right, now what I want you to see here is that I have a 45-45 right triangle. Okay, and I know this is a right angle down here, and I'm given that this is 45. So what I know is that this is length L, this is length L, and this length here is L times the square root of 2. So if I find length L, then I can find my height. So what I want to do is I know that these two things are equal. Okay, I know that 7 is equal to L times the square root of 2. All right, and I can solve for L. I can divide by the square root of 2 on both sides. All right, so I get that my length L is equal to 7 divided by the square root of 2. Now, we don't like to have square root of 2 in our denominator, so I want to multiply the numerator by the square root of 2 and my denominator by the square root of 2. And so that's going to end up just giving me 7 times the square root of 2 divided by the square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is just 2. Okay, so if I multiply square roots by itself, it just gives me what's underneath the square root. And this is my height. Okay, that's that length here. All right, so if I wanted to find my area, then I would simply just take my base, which is 14, and I would multiply that by 7 times the square root of 2 being divided by 2. Now, this is being divided by 1. Now, you can kind of multiply this out and see what you get, divide this by 2. But what I notice here is that 14 and 2 divide out. 14 divided by 2 becomes 7. So I get 7 times the square root of 2. Okay? And so when I do that, I end up getting that my area is 49 times the square root of 2. Okay? And so if I plug that into the calculator, I get an approximation of 64.3 yards, 64.3 yards squared, okay, and that's my area, okay. So now let's take a look at the next one. The next one's similar to the one we just had, but what I have here is I have another parallelogram, okay. Again, I know that these segments are congruent, so I know that this is 30 centimeters. I know that these segments are congruent, so that this is 20 centimeters, all right? And so my perimeter would be 2 times 20 plus 2 times 30. All right, and that's going to give me, what is it, 40 plus 60, which ends up giving me 100 centimeters, okay, for my perimeter. All right, now let's take a look at our area. Now, area is a little bit tricky because we have this length here. It doesn't really look like it's the height, but is the vertical distance from this point down to this point. It makes a right angle, so I know that that's the height. Now, my base is this measurement down here. Okay, that's my base. My base is equal to 20 centimeters. All right, so if area is equal to base times the height, I need to find my height here. Now, what I notice here is that this is a 30, it's a 30-degree angle. This is a 30, 60, 90 triangle. So I know this. I know that this is length 2s. I know that this is length s. And I know that my height is the length of s times the square root of 3. So if this is 30, this is double this length, I know that s is equal to 15. It's half the length of this hypotenuse. So then I know that my height is equal to s times the square root of 3. So I get that my height is equal to 15 times the square root of 3. Okay, so I have my height and I have my base, and I can plug it into my area formula. So now I have my area is equal to 20 times 15 times the square root of 3. Okay, and 20 times 15 is going to end up giving me 300. So I get 300 times the square root of 3. This is my exact area, but we want to round to the nearest tenth. So we get an approximate area of, what is this? 579.6, and that's centimeters squared. Okay. All right. That's what I got. All right. Let's take a look at the next couple. The next couple are pretty tricky, okay, especially number 4. And we've talked about quadratics, but we're going to have to solve a quadratic here. So it says the height of a parallelogram is 10 feet more than its base. If the area of the parallelogram is 1,200 square feet, find its base and height. So what I want to do is I want to come in here and just kind of draw a generic parallelogram. And what I know about this is that the height, and this is my height here, and that's the vertical distance down that makes a right angle. Okay, so you can draw that in there. My height is 10 feet more than its base. So when I see that, 10 feet more than its base, then I'm going to call the base length x. Okay? And so if my length here is x, because it's not given to us, then I can say that my height is 10 feet more than the base. So I'm going to write that this is x plus 10. All right? Now I know this, that my area is equal to the base times the height. Now I know that my area is 1,200. I know that my base is equal to x. I know that my height is equal to x plus 10. So what I can do is I can substitute those values into my formula, and I get an area of 1,200 is equal to my base. Now my base is x, and I'm going to multiply that by my height. Now my height is the quantity x plus 10. So what I can do here is I can distribute my x, all right, and I'm going to get a quadratic. I'm going to get 1,200 is equal to x squared plus 10 times x. Okay, now this is something that's kind of brand new to us, and we know how to solve something with x squared equals a number, but we can't do it with another x. So what I have to do is I have to subtract 1,200 from both sides. Okay, and so I end up getting this. I end up getting 0 is equal to x squared plus 10x minus 1,200. Now this is a quadratic. Okay, I am going to solve this by factoring, and I have to ask myself, what two numbers multiply to negative 1,200 and add to 10, positive 10? Okay, and you kind of got to play around with this. This one's kind of tricky. It's not very easily seen. But I know those two numbers are going to be negative 30 and positive 40. If I multiply these two, I'm going to get negative 1,200. If I add these two, I'm going to get 10. So I can factor this, and I can say 0 is equal to x minus 30 times x plus 40. And if I multiply all this stuff out, I'll get my quadratic. But what I can do is I can solve for x. I know that this value, x minus 30, is going to equal 0. I know that this value, x plus 40, is going to equal 0. So I'm trying to find what values for x will make this true. And so if I add 30 to both sides here, I end up getting x is equal to 30. And then here I get x is equal to negative 40 if I subtract on both sides. So now my question is, which one of these values for x are we going to use? Are we going to use positive 30 or negative 40? Well, remember, guys, that x is a distance, and a distance is always positive. So we want to use 30. Okay, so x, my base, is equal to 30. And then my height is equal to x plus 10. And if x is 30, I get 30 plus 10. And I get that my height is equal to 40. And so this kind of verifies what I have, and this is in what, feet? I can verify that these are the right numbers because if I take 30 times 40, I'm going to get an area of 1,200. Okay, so that's how we do number 4. Let's take a look at number 5. Okay, and let's just draw a generic triangle here because it's a question about a triangle. All right. Oops. I don't need 2. I just need 1. All right. So, okay, half the height. All right. So what I know is that I've got this length here going from the very top of this. This is my height. Okay, it makes a right angle. And this is my base. Okay, now what I know is that the base of the triangle is 1/2 of its height. So if I called the height x, then I would call the base length half of x, which is either x over 2, or you could say 1/2 times x. Okay, either one. So now let's find the area. Okay, sorry, we know that the area is 196. Let's write out our formula. Area is equal to, and I'm going to use this version, I'm going to use 1/2 times the height, which is x, times the base, which is x divided by 2. All right. Now, these are 3 fractions that I'm multiplying together. Okay. And what I also know that my area is 196. So let's write this. Let's write 196, which is my area, is equal to 1/2 times x over 1 times x over 2. Now, this is just x. Okay. It's being divided by 1, and this is being divided by 2. Now, what I want to do is I can just multiply all my numerators together, and I can get 1 times x times x. That's just going to give me x squared. Okay, and then I take 2 times 1 times 2, which is going to give me 4. So x squared divided by 4 equals 196. Now, what I can do here, if I'm solving this for x, I'm going to multiply both sides by 4. Okay, and so 4 divided by 4, those divide out. I get x squared is equal to 4 times 196, which is going to be 784. All right, and I want to solve for x. Now, this we know how to solve. Okay, this we know that we can just take the square root of both sides, and I'm going to get that x is going to end up actually being 28. Okay, so then I know that my height is equal to 28, and I know that my base length is half of 28, so it's going to be 14. And what is this? Millimeters. Make sure your label. Okay, so I know this video is kind of long, and there's a lot of information on it, but you know, these are things that I think we were able to do. It may stretch you a little bit, but you are capable of doing these. So please get started on your 11.1 homework once you have completed this. Thank you.